Good morning, children. Welcome to the chemistry class. Today we are continuing with the chapter periodic table. In the last class we were discussing about Mendeleev's periodic table, how Mendeleev formulated the periodic table, about the periodic law which was put forward by Mendeleev, about the advantages of his periodic table and also his limitations. So, after a long time, after the limitations of the Mendeleev's periodic table, there came another chemist. His name was Henry Moseley. Okay, so he tried to find out. And also he tried to rectify the limitations of the pre-existing periodic table. And after a lot of studies, which was conducted by X-ray diffraction technique, he put serial numbers for the elements, and those serial numbers came to be known as atomic numbers. And he made a slight correction in the periodic law which was put forward by Mendeleev. And the correction he did was that the physical and chemical properties of elements are periodic functions of their atomic number. Okay, once more I'll repeat. The physical and chemical properties of elements are periodic functions of their atomic number. Earlier, when we discussed about this John Newlands, Dobereiner as well as Mendeleev also, they arranged the elements. They tried to arrange the elements according to the atomic mass. So that was a major mistake done by them. So through the diffraction studies, X-ray diffraction technique, Henry Moseley, he corrected the periodic law, and this is now known as the modern periodic law. So the modern periodic law states that the physical and chemical properties of elements are periodic functions of their atomic number. Okay, so now we are going to the periodic table which we are seeing in our text now, the modern periodic table. So first I am going to explain to you some of the elements. We are going to find out what are the similarities of the elements. Okay. So here we are going to study about the electronic configuration. Electronic configuration and its position. Okay, and its position. Okay, so I am going to write hydrogen, lithium, sodium, potassium, rubidium, cesium. Okay, so here I am going to write the electronic configuration of some elements and its position in the periodic table. So as you all know, the atomic number of hydrogen is 1. Okay, lithium is 3. So its electronic configuration will be 2, 1. Here it is 1. Okay. Now about sodium is 11. So we will be writing it as 2, 8, 1. Potassium 19. Okay, 2, 8, 8, 1. Okay, I think the atomic numbers of these elements are much familiar to you, like lithium, sodium, potassium. Then comes the rubidium and francium, which is placed on the left hand side of the periodic table. Now next is 37 and 59. Okay, so here also when we write the electronic configuration of the elements, you can see it as 2, 8, 18, 8 and 1. I think. Yeah, 2, 8, 18, 8 and 1. Then comes 59, that is 2, 8, 18, 18, 8 and 1. Okay, So here we can see a list of elements which I have written here. That is hydrogen, lithium, sodium, potassium, rubidium, cesium. One more element is there, that is francium, which is a radioactive element. So I have written the names of the symbols of some elements here. Its atomic number is written here and the electronic configuration is written here. So if you are checking the electronic configuration of the elements, the outermost electrons in the outermost shell, 1, 1, 1, 1, 1, 1, isn't it? So you can see that even though the atomic number is increasing, you can see that the atomic number is increasing downwards. So even though the atomic number is increasing, when we write the electronic configuration of the elements, you can see that the electrons in the outermost shell is 1 for all the elements. Okay. So from this what we can understand, the elements whose outermost shell, the number of electrons of those elements which is having only one electron in the outermost shell or the valence shell, they are placed together in one group. Okay, they are placed in one group. Those elements whose outermost shell has only one electron, they are placed in one group. Okay, now next one, I am going to write another set of elements. Okay, here beryllium. So here I have written another set of elements, that is beryllium, magnesium, calcium and strontium. So here I have written another set of elements, that is beryllium, magnesium, calcium and strontium. That is atomic number is 2. Atomic number of beryllium is 2. Magnesium it is 12, calcium it is 20, strontium it is 30. Now I have written the electronic configuration here. 2. Here 282 magnesium, 20, 2882, strontium 38, 2818, 8 and 2. So here also, like we discussed in the last set of elements, the electrons in the outermost shell remains the same. Even though the atomic number is keeping on increasing, the number of electrons in the outermost shell remains the same. So from this what we can understand, the outermost shell, how many number of electrons are there in the outermost shell, that will tell you the group number of the element. So for example, see here lithium, okay, it's 2 and 1. Then magnesium, it is 2, 8, 2. Potassium, it is 2, 8, 8, 1. Then calcium, 2, 8, 8, 2. Okay. So if a list of elements is given like this and they are asking you to find out the group number, how can you easily find out? So you have to find how many number of electrons are there in the outermost shell. If the number of electron in the outermost shell is 1, it belongs to group 1. Group 1. So here also potassium, the outermost shell or the valence shell contains only 1 electron. Then it belongs to group 1. Here in magnesium, the number of electrons in the outermost shell is 2. So it is group 2. Here also in calcium, the number of electrons present in the outermost shell is 2. So it belongs to group 2. So from this you can also understand one thing, that those elements which are placed in the same group, okay, those elements which are placed in the same group will be having similar chemical property. Okay, those elements which are placed in the same group will be having the similar chemical property. Now after we have discussed about group 1 and group 2. Okay, I am going to write a new set of elements. Group 13, 14, 15, 16, 17 and 18. Okay, so I am 50. Okay, so this is group 13, group 14, 15. You can also look at the periodic table in your text. Okay, 17 and group 18. Now, I am writing the name of the elements. Okay, boron. Atomic number is 5. Electronic configuration 2, 3. Okay. Nitrogen. Group, not nitrogen. Carbon. Atomic number 6, 2, 4. Here. Nitrogen. Atomic number 7, 2, 5. Then oxygen 8, 2, 6. Fluorine 9, 2, 7. Then neon 10, 2, 8. Now here I have written the first member of group 13, group 14, group 15, group 16, group 17 and group 18. When we discussed in the earlier two elements, that is group 1 and group 2, when we wrote that elements in the order according to the atomic number, I told you that the number of electrons which is in the outermost shell shows us the group number, isn't it? So when we wrote the elements from hydrogen to cesium, we could find that even though the atomic number kept on increasing, the number of electrons in the outermost shell was 1. Next time when I wrote the elements beryllium, magnesium, calcium and strontium also, the group number, the outermost electron in the shell, the valence shell was 2 only. So I told you that if the number of electron is 1, you can classify it as group 1 elements. If it is 2 electrons in the outermost shell, you can classify it as group 2 elements. But here it is group 13. It's not group 3, group 4, group 5. It's group 13, 14, 15, 16, 17, 18. And I have written the first element of group 13, first element of group 14, first element of group 15, first element of group 16, first element of group 17 and first element of last group, 18th group. But can you see 13 or 14 or 15 here? No. You can only see that the outermost electron is 3, here 4, 5, 6, 7 and 8. Now what is the difference between these elements? 13 minus 3, here 10, 14 minus 4, 10, 15 minus 5, 10, 16 minus 6, 10, 17 minus 7, 10 and 18 minus 8, 10. So in all these elements, there is a difference of 10 here, you can see, isn't it? So from group 13 to 18, if you want to find out the group number, what you have to do? Just add 10 to the outermost electrons. Just add 10 to the outermost electrons. Then you will find the group number of those elements. Okay, that is here you can see that is a boron. It is having 2, 3, isn't it? If you want to find the atomic number, what you will do? You will add 10 to it. For example, I'm going to write the electronic configuration of some elements. Okay. Aluminium, phosphorus, then chlorine, argon. Okay, here I am going to write the atomic number. 13, 15, 17 and 18. These are the atomic numbers of some elements. Now I am going to write the electronic configuration. See, 2, 8, 3, 2, 8, 5, 2, 8, 7, 2, 8, 8. Okay. So here if you want to find out the group number of these elements, what you have to do, if the outermost electron, if the number of electrons in the outermost shell is like this, 3, 5, 7, 8, etc. What you have to do? Just add 10 to it. Just add 10 to it. So you can understand that this belongs to the 13th group. This belongs to 15th group. This belongs to 17th group. And this belongs to 18th group. Okay. So this is how we are going to find out the group number of elements. So for group 1 and group 2, it is easy for you to find out. Just write the electronic configuration. If the outermost shell contains only one electron, it belongs to group 1. If the number of electrons in the outermost shell is 2, then it is belonging to group 2. Next, if the number of electrons in the outermost shell is 3, 4, 5, 6, 7, 8, etc., just add 10 to it and find out the group number. So, we will be discussing more examples when you are coming to the school. Okay, related to this electronic configuration and finding out the position of elements in the group. This chapter is really very important because you will be having a chapter, a continuation of this chapter when you come to the 10th standard. So, you have to be very clear with this chapter. Okay, so please try to write in your own these elements, write the electronic configuration and find the group number. So, thanks for watching. This is all for this week. Thank you.